Two spherical planets P and Q have the same uniform density rho, masses MP and MQ, and the surface area A and 4A respectively. A spherical planet R also has uniform density rho and its mass is MP plus MQ. The escape velocities from the planets P, Q and R are VP, VQ and VR respectively. Then we have to arrange them in order and find the respective ratios. So for this one, I am considering something like this. So let us say this is all about planet P. This segment will be all about planet Q, and this will be all about planet R. So we begin by a certain consideration. So we are saying that the density for planet P is rho, mass is MP, which I am supposing as M, so that we can find the ratio. Now apart from this, it is saying that the surface area is A. So density is rho, mass is MP, surface area is A. So from here I can say that mass of the planet can be written as density into volume. So density into 4 by 3 pi radius of P cube. So this is what we can write from here. So if I take the radius as R, it should not be confused with this capital R. So let us take small r over here. So I can write it as that the mass of planet P is rho into 4 by 3 pi r cube, and this entire parameter I am writing it as say m. So these are the things which we have about P. Now for Q, the question is stating that it is having the same density, mass is Q, which we will be calculating in terms of m, area is 4a. So now if we are looking for this particular one, so I can write from here that if the surface area is A and 4A, so I can say that A is implying 4 pi r square, that is from P, and 4A will imply that the radius of Q will become 4 pi rq square. So from here we can get that RQ is equal to twice of RP. So twice of RP means twice of small r. So this is what we obtain here. And if we calculate the mass, so I can write that mass of Q is equal to rho into 4 by 3 pi radius cube. So it will become 8 r cube. So we can write it as that the mass of Q is equal to 8 times of m. So mass of Q is equal to 8 times of m. So the notable facts which we will be using over and over again is mass of m as P, radius as r, and for Q the mass is 8m, the radius is 2r. Now the next thing which we talk about is the r. So for r the question is saying that the mass is mp plus mq. So mp plus mq will sum together to give us 9m. So the mass is going to be 9m. Now since the density is same for this material also, so if we wish to calculate the radius, so I can write density is equal to mass, that is 9m, by volume, so 4 by 3 pi rr cube. So rr cube. So radius of r cubed. So radius of r cubed, so radius of r will be obtained as we can write it in terms of the density is equal to mass by volume, that is 4 by 3 pi r cube. That is the initial value of P. So I am writing the initial value of P over here since density is same. So we have its radius in terms of P, that is 9 cube root of 9 into radius of P, that is r. So this is rr which we have. So I can circle the parameters over here as the mass of r is 9m and the radius of r is cube root of 9r. Now we need to talk about the escape velocity. So let us discuss it in the next page. So if I write the expression for escape velocity, So for escape velocity from any planet, so I can write it as VE is equal to root over 2 gm by r. So this is the value of escape velocity from any planet. Now for P, I can write Vp is equal to twice g mass of P upon radius of P. So we have considered the mass of P as m and its radius as r. So we get this value as gm by small r. Now the next one for Q, we write it as 2g mass of Q upon this. So we write 2g mass of Q is equal to 8m and radius of Q is equal to 2r. So we obtain it as twice of Vp. So it is coming out as twice of Vp, and if we calculate the escape velocity for r, so we will write it as 2g mass of r, that is 9m, and the radius is cube root of 9 into r, so 9 to the power 1 by 3 into r is square root. So from here we obtain it as 9 1 by 3 Vp. So these are the three expressions which we have obtained. So now if we start looking at the options, so the first one, the sequence which is it is talking is incorrect. The next one, the sequence which it is talking, that is Vr greater than Vq greater than Vp, is the correct alternative. So B is correct. And then it is talking about the ratio. So Vp by Vq. So we have obtained Vp by Vq is equal to half. So this is also correct. So B and D are correct alternative. The C option is again incorrect. So for this problem, B and D are correct alternatives.